artificial intelligence has transformed from a theoretical concept to a cornerstone of modern life. Its origins trace back to the 1950s, when Alan Turing posed a provocative question: can machines think? His Turing test challenged computers to mimic human conversation, but early systems were primitive, limited to basic calculations for scientific research. The 1956 Dartmouth Conference coined the term AI, sparking optimism about intelligent machines. Yet, progress was glacial. Computers lacked the power to handle complex tasks, and funding dried up during AI winters in the 1970s and 1980s. Early programs like the logic theorist could prove mathematical theorems, but they were narrow and clunky. Why did AI struggle in its infancy, and what barriers kept it from thriving? The 1980s brought expert systems, designed for specific tasks like medical diagnostics or factory scheduling. These systems relied on hand-coded rules, requiring experts to input vast knowledge bases, a slow, error-prone process. For example, Mycin, an early AI, diagnosed bacterial infections but needed constant human updates. Meanwhile, AI winners persisted as hype outpaced results, frustrating investors. The turning point came in the 2000s with the rise of big data. The internet generated massive datasets, search histories, social media posts, and e-commerce transactions, fueling a new approach: machine learning. Unlike rule-based systems, machine learning allowed AI to learn patterns from data, adapting without explicit programming. By 2012, deep learning, using neural networks modeled on the human brain, enabled breakthroughs in image recognition and language processing. How did this shift unlock AI's potential? Deep learning's rise was powered by three forces: data, computing power, and algorithms. Graphics processing units, GPUs, originally built for gaming, accelerated neural network training, making complex models feasible. In 2012, AlexNet, a deep learning model, won an image recognition contest by a wide margin, proving neural networks could outperform traditional methods. This sparked a race among tech giants. Google's DeepMind made headlines in 2016 when AlphaGo defeated a world champion at Go, a game with more possible moves than atoms in the universe. Unlike chess, where brute force worked, Go required intuition-like strategies, showing AI could think creatively. By 2020, AI was embedded in daily life. Siri answered questions, Netflix recommended shows, and spam filters caught junk emails. But early missteps, like image recognition mislabeling people as objects, exposed AI's flaws. What challenges did developers face in refining these systems? AI's integration into industries revealed its transformative power. In automotive, self-driving cars from Tesla and Waymo used AI to navigate roads, processing sensor data in real time. In retail, Amazon's recommendation algorithms drove 35% of sales by 2023, learning from user behavior. Healthcare saw AI diagnosing diseases from X-rays with accuracy rivaling doctors. Yet, scaling AI wasn't easy. Biased datasets led to errors, like facial recognition misidentifying minorities, and ethical concerns grew. The journey required relentless innovation, from Turing's theories to today's neural networks. Data growth, now doubling every 2 years, and advances like transformer models have kept AI accelerating. Where is this trajectory leading, and how will it reshape our world? The path from Turing to today wasn't linear. It took decades of trial, error, and breakthroughs to make AI ubiquitous. Each leap, machine learning, deep learning, real-world applications, built on the last, driven by human ingenuity. But the story's far from over. As AI grows smarter, its potential and risks are coming into sharper focus. The next chapter promises to be even more disruptive. How will it change the way we live and work?